Welcome to physics online session. So today I'll start next chapter, that is electric potential and capacitance. Okay, in this chapter, so we are going to discuss what is electric potential and electric potential due to point charge, electric potential due to system of charges, and electric potential due to dipole, and electrostatics of conductors, what is capacitance and what is its function, and parallel plate capacitors. So these are the topics mainly we are going to focus in this chapter. Okay, now I'll start with now what is gravitational potential. What is a electric potential energy? Before going to discuss electric potential energy, first we have to know what is the potential energy. Okay, see here, what is the potential energy? When the body will get potential energy. Okay, for example, external forces like this is Fg, okay, when external forces like when external forces do work, when work is done by external force against the conservative forces like spring force, gravitational force, elastic force, and coulombic force. Okay, so when work is done against these conservative forces, whatever the work done by external agency will be stored in the form of potential energy. Look at this example. Okay, here I took an example where a ball is lifted to a height h. Okay, now when the ball is on the ground, okay, its potential energy is 0. Okay, so but when it is lifted, so this lifting force is a external force, this is the external force, and this external force is doing work. Why? Because when there is a force and when body is displaced, work is said to be done. Now we are lifting this ball to a height h against what? A gravitational force. Now whatever the work done by us will be stored in the form of potential energy. When ball is lifted to height h, what will be the potential energy at point B, which is at a height h from the ground, will be mgh. Potential energy is mgh. Okay, so what happens to the potential energy? Increased when we do work. So the potential energy of the system, when we do work against the conservative forces like these four, so the potential energy of the system increases. No, this is the no. What is the change or what is the increase in the potential energy? Final potential energy minus initial. Final position, this is initial position. So change in the potential energy is equals to mgh minus 0. Therefore delta U is equals to mgh. This is the increase in the potential energy, so is equals to the work done. Okay, so this is my work done and this is equals to change in the potential energy. And remember one more point here, work done, what work done is independent of the path followed, independent of the path followed. Okay, whatever you take the path, the total work done will be same. It depends, the work done depends only on the depends only on initial and final states, independent of the path fall. For example, if you lift a ball from your intention is to lift a ball from A to D, okay, which is at a height h. Okay, so you can directly go in this. So this is the first path, second path. So this is the second path. You are going from A to B and B to C and C to D. So for let us take what is the work done in this path. So work done in the first path will be mgh. So why? Because work is equals to force into displacement, F bar dot F into S kada. So F nothing but minimum we need to apply force, which is equals to gravitational force md into h, mgh. Here what is the work done? Actually F bar dot ds bar, S bar, F bar equals to Fs cos theta. So here the angle between the force and displacement is 0, cos 0 is 1. Here the gravitational force is downward and displacement is towards left, so therefore work done is 0 here. This is work done 0 here, once again mgh, so here is 0. So total again, what is the total work done? 0 plus 0 and mgh, total work done again is same. We can say that work done depends only on the initial and final state, but not on the path followed. Whatever the path you take, you can go directly like this, so the path, that work also will be same. Okay, right. Next no, we will discuss here actually I'll come to actual topic, that is electrostatic potential, simply electric potential energy. Electric potential energy. Okay, and let us consider a charge capital Q is placed in the space at the origin. Let us take it is at the origin, and so I am placing one more. I want to move a small positive charge, small q, so from one point to another point. Here this is a plus q. Now this capital small q is said to be in the field of capital Q. No, it is in the electric field. Small q is said to be in the field of capital Q, and capital Q is also said to be in the field of small q, but it is a small charge. This is a test charge, its magnitude is small. Okay, now let us move this point charge from point B to point A. Why I am moving? Already I told that when work is done by the external force, okay, so against the conservative forces, whatever the work done by us will be stored in the form of potential energy. Here also the work here we are doing work in displacing plus q from B to A. Whatever the work done by us in moving plus small q from B to A will be stored in the form of electrostatic potential energy. Okay, so what type of force exists between plus capital Q and plus a small q? There exists a repulsive force, that is called electric force, Fe, repulsive force. So why? Because similar charges repel each other, so plus q repel plus a small q. Okay, this is away from plus q, but against this repulsive force we have to push, we have to push plus q towards capital Q. Okay, external force is opposite to the direction of Coulombic force or electric force. Okay, now therefore work done, therefore electrostatic potential. So what we have to, first I want to know what is electric potential energy difference. The sorry, take another one. The work done in moving, work done in moving, test a charge, moving a charge, work done in moving a charge from moving a charge q, charge plus q from B to A is given by the definition of work. So we know that W, so we are bringing charge from point B to point A, therefore WBA is equals to so you know this expression, variable force expression, since when the charge comes here, the force experienced by it is different, so it is a variable force. So that is by work done by variable force is this expression. WBA equals to integral WBA is equals to integral B to A. We are moving a charge from B to A, and this is external forces are doing work. Therefore, F external bar dot dr bar. This is a work done against work done by the external force. Okay, here here F external, F electric is equals to, it is opposite to, sorry, I'll remove it. Okay, F electric is equals to negative of F external. Okay, so it is opposite in direction. This Fe and Fr, this is Fe and F external, both are in opposite direction. So we can write it as Fe equals to minus F external. So that implies, so work done in bringing moving a charge, a small cube from B to A is given by minus integral B to A F external bar dot dr bar. Okay, so whatever the work, what I told, whatever the work done by external agency against the conservative force will be stored in the form of potential energy. Here we are moving from one point to another point, so therefore, so whatever the work done is called the potential energy difference. Therefore, the electric potential energy difference here, electric potential energy difference is the work done in moving a positive charge, in moving a charge from one point to another. Okay, this is electric potential difference. Okay, now if point B is taken at infinity, then above expression become W infinity A, sorry, is equals to minus integral infinity to A F external, I wrote wrong expression here, I did not replace with Fe here. So when you replace F external with Fe, so what do you get? Minus Fe. Okay, this is in terms of electric force. Okay, so this, the previous one in terms of external force, this is in terms of electric force. Therefore, Fe bar dot dr bar, let it be equation number 2 and let it be equation number 1. Okay, so what is this? Work done in bringing a positive charge from infinity to at a point A is called the electric potential energy. Therefore, this is the electric potential energy difference. No, the electric potential energy is the work done, in moving a charge, from B, from infinity to a point at any point in the electric field. Okay, so this is a work done. So we know that the change in the work done is equals to whatever the work done will increases the potential energy. Therefore here change in the potential energy is equals to what? Here the initial position is change in potential energy, delta U is equals to final minus initial, that is equals to what is the final? A minus initial is B. Therefore change in the potential energy can also be written as that is equals to UA minus UB. This is a change in the potential energy, UA minus UB. Here the change in the potential energy UA minus U infinity, that is equals to UA. Okay, this is sorry, right. Next what is electric potential? Next topic, electric potential. Electric potential, same definition here. No, when you bring a positive charge from here, see the figure once, here we are moving a positive charge. When you bring a positive charge from B to A, okay, so that will be stored in the form of potential energy. We call it as electric potential energy. If you bring a unit positive charge from one point to another point in the electric field, that is called electric potential. So I'll write the definition first. So the electric potential, simply I'll write it as electric potential at any point, electric potential at any point in the electric field, is the work done by the external force in moving unit positive charge from one point to another, is called electric potential, at that point, okay. So it can be represented as one point to another point is called electric potential difference. Here this is electric potential difference. Therefore so VA minus VB equals to U 1 by Q into UA minus UB, or work done in bringing a charge from B to A, unit positive charge, work done per unit charge, nothing but the electric potential. Okay, so work done in bringing unit positive charge, work done per unit charge is called electric potential difference. So how can you write this expression? VA minus VB is equals to what is WBA, 1 by Q into, so minus F electric bar dot dr bar, so B to A. Okay, simply we can write this expression as, so VA minus VB is equals to minus 1 by Q integral B to A FE bar dot dr bar. This is electric potential difference between the 2 points. Okay, now what is electric potential? If B is taken at infinity, then we can write then above expression becomes VA minus V infinity, so minus 1 by q integral b to a f e bar dot dr bar, f e into dr bar. Okay, so V infinity, electric potential at infinity will be 0, so therefore V a equals to minus 1 by q integral b to a f e into dr bar. Okay, so what is the relation between electric field and electric force? Electric field, we know that electric field E bar is equals to F bar by Q. That implies F E is equals to Q into E bar. Therefore, V A can be written as minus 1 by Q integral b to a Q E bar into dr bar. That implies V is equals to Q got cancelled. What do you get? Minus B to A electric potential at n. Here I forgot to write here B is taken at infinity. Yes, here B is taken at infinity, so I need to write this is B is taken at infinity, so infinity, and here also infinity. Okay, here B is taken at infinity to A, so Q got cancelled, so minus E bar dot dr bar. Therefore, electric potential at any point in electric field is given by integral E bar dot dr bar. Okay, so this is about electric potential. How can you define it? So the work done in bringing a unit positive charge from infinity to a point in the electric field is known as electric potential at that point. Okay, so this is about the electric potential. So once again I am repeating, I want to repeat what is electric potential. What is electric potential energy difference? Okay, here work done in bringing a moving Q from one point, from B to one point to another point is called electric potential difference. What is electric potential energy? So work done in bringing from infinity to A. Next, what is electric potential? Simply electric potential difference. This is energy difference, this is simply difference. So work done in bringing unit charge, this is unit charge from B to A. So what is electric potential? Simply electric potential work done in bringing unit charge from infinity to A, difference. So if you bring a charge Q from B to A, that is called electric potential difference between B and A. If you bring a charge Q from infinity to A, that is called potential energy at point A. If you bring a unit charge from B to A, that is called electric potential difference between 2 points. Here electric potential, if you bring a unit charge from infinity to at a point A, you will get the electric potential at that point.